This is episode 11 of Soundproofist, and my name is Carrie.
And this is Phil.
Today we're going to talk with Michael Stocker, the founder and director of Ocean Conservation Research. Michael is an acoustician, a musician, and an environmentalist. He's been researching and educating people about the impact of noise pollution on marine life since 1992.
I was really looking forward to talking with Michael today. I started following his work when I came across his YouTube videos explaining the hearing systems of fish. Later, I read his book, Here, Where We Are, which is an excellent interdisciplinary overview of how humans and non-human animals hear in their environments. I highly recommend it for anyone interested in bioacoustics or acoustic ecology.
When we did this interview over Skype, all of us were in lockdown because of the coronavirus. So we chatted about that too. In fact, Michael had some pretty interesting thoughts about our post-COVID future, kind of like this.
We're trying to beat stress, and we're actually in cultural shock right now. And I think people, I'm coming to work, but I'm not being as effective because I'm, just kind of muddling around in this very bizarre time we're in. And it also gives an opportunity here that we might be able to take because there's some wake-up calls going on. Hopefully it'll give us an opportunity to reset. The neoliberals will want to basically put the card table back up on its own feet and grab all the jigsaw puzzle pieces and put them all together like it was before. But it's not going to happen.
A lot of people who listen to this podcast may not really know very much about acoustics at all, and some people do when they're in the industry. But I thought maybe if you could just give an introduction of, how you got in the field of bioacoustics, what led you to what you're doing now.
If I looked at it from where I started out, sitting on a piano bench next to Miss Breitner when I was 4 years old, it would have looked like a very convoluted path. But when I look back from where I am at this point, it actually seems like a pretty straight shot. Everybody in our family had to learn some instrument, and my brothers were given a trombone and violin respectively, but I could knock over a glass of milk from 10 paces, so they decided to put me in front of a piano so I wouldn't knock it over. And I studied, and I loved it. So I, became a musician through that, and I really wanted to be a biologist, a marine biologist particularly, so my mom supported that. We had aquariums all over the house, and, I knew the last names of all the fish and things like that. And I was really into that particular trajectory. I got to high school. High school was pretty boring for me, and I was kind of looking for something exciting. And when the biology class came up, I said, this is going to be great. But Mr. Troutner managed to make biology boring. He was such a tedious person. I said, if biology is that, I don't want to do it. So I flipped back into music, and I started, pursuing in bands, and I got into the music industry. And I realized when I was in the music industry, particularly working in recording studios and things, that the people who got paid most reliably were people who were technical, who understood electronics, acoustics, and the other kind of support stuff around the music, and you didn't have to necessarily wear spandex. So I got into that, and I studied, acoustics and electronics. I took an engineering class actually through Eastman School of Music, so it was still, associated with music. And I made a reasonable career. I fed myself and sometimes others as I was working in the industry. And I studied. I went to Caltech. I studied electronics and magnetics there, and kind of got pretty conversant in the language of science, and biology was still a passion of mine. And in 1992, the Navy particularly was proposing this program. It was called Acoustic Tomography of Ocean Climate. And while the ocean climate component of the thing, so what they were doing, essentially proposing projecting sound across ocean basins. And by projecting sound across ocean basins, there's a correlation between the speed of sound and the density of the material it's in. And in the case of the ocean, it had to do with pressure and had to do with temperature. So you could actually measure the climate of the ocean and really kind of, instead of having a bunch of sensors everywhere, you had one big sensor that really determined the temperature of the ocean. And That was a beautiful idea. It was proposed by a guy named Walter Munk, and Walter, a brilliant oceanographer, but he was not a biologist. He was a physical oceanographer. And I saw that and said, this is a bad idea because they're going to put noise in the ocean and it's going to disrupt the communication and just the environment. I mean, you can imagine having this beeping going on or this actually fairly low roaring going on every, matter of minutes in your life for the rest of your life across ocean basins.
Yeah, horrible.
So I went to the public hearings about this program, and I soon found that there was two different sides of this that were, they were not able to talk to each other. There were the scientists and physical oceanographers who understood mathematics, understood physics, understood the ocean from that standpoint. And then there were the environmentalists who were largely not conversant in science. They were passionate. They understood sympathetically or empathically what the critters in the ocean were suffering or would be suffering. And so I found a niche where I could actually communicate kind of across that line because I understood the mathematics and I also understood the empathic biological side of it. So that's where I landed in 1992. And then, I worked with it for years. I'm still working on it at this point. Through the 90s, I was working at doing applied physics for a company that was doing biomimicry work, PAC Scientific. That's an interesting company. But I was also doing other kind of contract work and designing recording studios and designing power supply. I was doing all these kind of technical things and doing this pro bono work when I was showing up at public hearings and writing critiques of environmental impact statements and things like that, all the way up to about 2000. And then I got together with some other folks who were passionate about it, who were more organized than I was as far as public coordination, organizing some communications and things like that. And so we started an organization that was looking at this issue of noise in the ocean specifically. And as I was getting into this, initially the Navy was proposing this low frequency active sonar program, which was a kind of an offshoot of the acoustic tomography, again, with low frequency signals that they were kicking across large ocean basins, and they were loud. And as the hearings were happening on that, there was a very tragic incident where the Navy was doing exercises in the Bahamas, and it resulted in the stranding of 17 Cuvier's beak whales and one minke whale as a consequence of the noise that they were subjecting these animals to. And so all of a sudden it came up on everybody's, sonar. It was like, oh my God, noise is a problem in the ocean. And that kind of kicked things into gear. And I ended up continuing to work for PAX for a little while, but I realized I needed to really focus my attention on this. So I ended up starting Ocean Conservation Research to really specifically focus on the impacts of human-generated noise on marine habitat. And that was, I think, in 2006.
Yeah, I'm curious to know, have you met a lot of resistance from industry and, corporate interests and other interests that, have had some resistance to your message and your attempts to preserve ocean life and protect them from unwanted harmful noise?
Well, for the first 4 or 5 years, the Navy was in complete denial about it. I wrote a couple of papers about other animals are being impacted, not just whales and dolphins and protected animals, but also I've got a paper that seems to be pretty popular still. I wrote in 2002, which talks about mollusks and other invertebrates and fish and how they're being impacted by sound. The Navy was in denial about it till about 2004. And then I think they finally realized, because every time I told somebody what I did for a living, the first thing that would come off their lips was the Navy, And so I think they realized that mitigating for bad public opinion was more difficult and more costly than actually doing the right thing. So they began funding research and also responding to the research and doing things like ramp up and other stuff that they were essentially decreasing because, you follow the Navy around for the first, from 1998 through 2006, 2007, there was always disasters. There's always strandings around where their operations were happening. And a lot of it had to do with the way they were using sound in the ocean or noise in the ocean. And so they started coming around. My whole shtick is not to, because people used to say, well, thanks for fighting the Navy on us. You don't fight the Navy. The Navy are pugilists. That's what they do that's what their remit is. So you don't fight them. you attempt to, basically recruit them. And I did that for years, and I had pals in the Navy, and also in industry. It was interesting because the oil industry, as you know, they're a force to be reckoned with. And there were people in the oil industry. I mean, I was involved in the FACA, the Federal Advisory Committee, on coming up with a white paper, instructing Congress how to use the data on the noise impacts in the ocean, craft policy, the direct policy. And we had the Navy and industry on one side of the room, and we had the environmentalists on the other side of the room. And it was a total disaster in 2002. But I ended up becoming friendly with some of these folks on the oil and gas side, just as pals, because, you have these conferences, and they're in New Orleans, and they're in Seattle, they're in places where, after the conference is over, everybody kind of huddles with their own group. But I would not huddle with my own group necessarily. I'd go hang out with some of the folks from the oil industry and just, be pals. And so I managed to recruit some pretty valuable inside information because these guys, they realized I wasn't just a flailing enviro terrorist, that they realized I was actually a guy like them.
Yeah.
And that helped out a lot.
With valid reasons for doing things.
Yeah.
Are a lot of people working, specialists in this particular field? Or are you one of the few? Or, do you need more?
Well, we always need more. But marine bioacoustics, I mean, one of the things that I'm missing this month is there were two conferences. One, Ocean Noise Conference in Barcelona that was basically coordinated by a guy, Michel Andre, who teaches at the university there. They're academics who are doing a lot of stuff, and they're a tangential group, people who are, with the military, with the Navy, with spar wars and things like that. So in terms of marine bioacoustics, I mean, I can't name them all personally, but I think there was going to be about 300 people at this conference, and 100 of them were going to be students, and 200 of them were going to be people who actually work in the field. So it's not what you call a crowded field, but most of the people are academics or they work for industry. I just did a project with NOAA, Manolo Castellotti, who works in University of Washington, but he works up in Alaska, who is looking at beluga whales, mostly what he studied. But we ended up doing a project monitoring a seismic survey that was happening up there. And they had the equipment, and I had the swiftness of foot to get the project going in time. Yeah, so, you kind of, after 20 years, I know most of the people who were involved in it, but it's really nice to see other people coming into it. I think we are the only organization that's really specifically focused on this as our remit. Ocean conservation research is just, that's what we do. Noise pollution in the ocean. I think we're the only. And so, NRDC has, folks like Michael Jasny who are working on it. Other organizations, Oceana's got, Laura Levinson, who's focused on this. So, they have, but those guys are, they're like $30 million operations. we're just a little small buds here.
Yeah, yeah.
But we're pals, we work together.
Your trip to Mexico recently, was that related to your work, or were you just taking a break?
Somewhat. I've been taking groups of people down to Baja California since 2006 to visit the friendly whales of San Ignacio Lagoon. So it's associated in as much as, I forget who it was who said, when you wake up as an environmentalist, you want to figure out if you're going to spend the day saving nature or savoring it. This was a savoring thing.
I noticed that, in your book, you encourage people to really listen to the soundscape around us and, not just the noise, but also what we think is silence.
Yeah.
Is that something that you do in some of these group events, sort of like learning to listen?
I'm not really, I don't actively do that with people. There are people who are, who are listening groups and things, like World Listening is an organization that does this, and they do soundscape or sound walks and things. But, I approach the world by ears, and I'm not highly visual. It's surprising to me that it really helps sometimes. And I remember giving a lecture at the University of Dominican University here in San Rafael area. And it was, it was in the afternoon. It was well after the lunch crash. It was like 5 or 6 in the afternoon or early evening. And I used to not do PowerPoints. I used to just speak because I thought it was important for people to just gather. It was kind of like Ivan Illich and working in a situation without a microphone. You say, okay, just speak, and people are going to be in that sensation. But half of the students were like falling asleep, and the other half were like jumping at the on the edge of the chair. So I said, well, this is interesting. If I had a picture, or a film of Minnie Mouse doing the can up on a screen, I think the other people would be awake. They need visual engagement, and auditory engagement works for me. I started doing PowerPoints after that, and it works better, frankly, because you can't get everybody on the same, auditory band if they're not accustomed to it. I mean, it's also what people hear and don't hear.
Yeah.
I mean, so many times I've did a presentation at the Oakland Museum one time, and as I was going to my car, I heard these two people in front of me who were also going to their car, and they were saying, "Boy, I don't believe it," and they. What they were saying that they heard was like, I didn't say that. It was totally wild. So they had, so people have this narrative continuously going, which helps reinforce who and where they are. And some of them are auditory and some of them are visual. And they're always based on our own internal truths.
Well, I think all of those things factor in, cognition, people's own personal filters, and yeah, exactly, their own personal truth. And also what you tend to focus on. And you also covered topics in your book about how different species of animals hear, and about the hearing systems of ocean life, which of course is your main thing, is dealing with not disrupting these ecosystems because of how important it is for them to use these other means of hearing. How have we've covered some of this in a way, but how do you think human activity, environmental damage, and commerce have impacted their environment over the long term?
Well, I think what's really important to understand is that the ocean is not a visual environment. If you get down, in really healthy water, it's just turbid because it's got a lot of zooplankton and phytoplankton in it. And so you can't see very far. In the best of conditions, in really tropical waters, you might be able to see as far as 100 feet underwater if you're in shallow water. But if you get down deep, there's no sunlight down there. And anybody who's a diver knows you get down 10, 15 feet, all the red goes away. You just see blue and green. And you get down a few hundred feet, and there's absolutely the only light down there is bioluminescence from the animals that are generating it. And that's their communication system. But that is something, it's very short distance. But you can hear sound hundreds of miles. In some cases, thousands of miles. I mean, there's a really amazing graphic that I have, which is the sound of a humpback whale's vocalization, which is heard in hydrophones around the entire Pacific, literally 3,000 miles away. And so these animals don't make those sounds just to be loud. There's a reason. There's an adaptation that they have where they make a sound that can be heard 3,000 miles away. There's something 3,000 miles away that's important to them, or important to the 3,000 mile away target. So sound is really, and that's just one species of whale. And we have fin whales, the whole series of rorquals, which are the fin whales, blue whales, binkies, Rudi's whales, and sei whales. They pulse like cricket. That's what they do all the time. They're just boom, boom, boom. And some of the pulses, like the blue whale pulse, might be 15 seconds between pulses. But what are they doing with that? Why are they pulsing that way? And my speculation is that they're like crickets, they're synchronized. They have some kind of a synchronous pulsing thing they do. And I have some evidence of this in minke whales. We're trying to get a couple of projects going on here where I'll be able to actually verify this, because we're going to have 2 hydrophone arrays that will be able to determine whether or not these are synchronized pulses between adjacent individuals, or if they're random or what have you. But that's how they use sound. I mean, and crickets use. It's nice hearing crickets crick, but they synchronize. Why do they synchronize? What are they doing there? So what seems to be happening with the crickets? You have all these crickets that are cricking away, and they're all synced together. They have an interesting neurological blanking that occurs when they're cricking. They can't hear anything. It blanks. So when the one single cricket is cricking, it's not hearing itself, And if there's another cricket nearby that's cricking and it hears it, it's easier to sync to a negative target. So they all sync, so nobody hears it. So when all the crickets, and this is cicadas, and it's all these kind of stridulating insects, when they sync like that, none of them are hearing what they're doing or what anybody else is doing unless somebody encroaches on their little community, their acoustic community there. And then one of them will slow down and all of them will say, oh, something's going on over there. So they have a community ear that basically allows them to determine the health, the boundaries, extent of what's going on in their surroundings. And so that's how they use sound. It's different than humans. It's different than giraffes, than horses. So every animal has got an adaptation to their sound acoustic surrounding that is unique to what their species is. There's acoustical niches, different frequencies that they use. And so when you get to the ocean, which is not a visual environment, the adaptations of various animals, whether it's fish or snapping shrimp or whales and dolphins, whatever, they all have their adaptations which are really specific to what their adaptation or other engagement with their surroundings is.
Very interesting. And what is amazing is, like, as you said, you can actually hear in this environment like thousands of miles. I think it could potentially be quite a cacophony. I've never dived, so I haven't experienced that.
Well, humans are not well adapted to hearing underwater. But one of the problems when they first started getting hydrophones in the water, there was a system of surveillance, SOSA system that the military put out, and they have these hydrophone arrays in the Atlantic, in the Pacific Ocean, listening for ships and things like that. But one of the problems that they had were all these noises, the damn blue whales, and just all this noise these animals would and that's, that when they put that system in, they started in 1957, that was probably the least amount of blue whales that were around because of the commercial industrialized whaling. And, if you talk about folks who were in 1820 who were applying the waters, they'd hear all these sounds from the hull of their boats. It'd give them the bejesus out of them. There was all these weird, strange pulsing and howling and screeching. So you see these old, 17th, 18th century, etchings of the ocean with all these strange beasts in it. That's what they could imagine.
Mm-hmm. Yeah.
And I wrote a paper in 2006 that was looking at the noise in the ocean prior to industrialized whaling. And if the numbers are correct that I work with, because there's no way to really determine accurate, nobody was putting hydrophones in the water then. But the ocean was noisier in 1820 than it was in 1920.
That's interesting.
By a lot.
Wow. One of your projects that you have going on right now is the Farallones Hydrophone Project. Is that underway right now, or is this a future?
We are working here. We have our team together. I'm working with Ellen Hines at the Estuaries and Oceans at San Francisco State University, Estuaries and Ocean Science, and Bruce Martin with JASCO. We are shy funding, but what happened, we're ready to submit. This next week I'm going to get into, and we have people who are interested funders in this, including NOAA. And this little coronavirus kind of got in the way. And also we did a project up in Alaska where we have huge amounts of data, which we have to start really combing through. So we're on the arc there. The funding is lacking, but there are enthusiastic funders. So I think we'll probably hopefully be wet in the water on that by mid or late summer.
Yeah, I hope so. Some of the other projects you listed that you have going on, citizen science, sailors, mapping ocean noise, acoustic journeys.
Yeah, the citizen science, as a nonprofit organization, the scientific work, we're kind of like carpetbaggers, because unlike people who are doing health and human service stuff where you say we're going to feed this group of people or we're going to address this homeless issue or what have you, a lot of people who are funders don't really understand exactly what's going on. So Citizen Science Sailors is a project that we've developed. It's kind of on the boards right now. We never were able to get adequate funding for the thing, and it would be a fun project. But I think what we're going to be doing instead, because what we really wanted to accomplish with that is that NOAA has a program called CET Sound, Cetacean Sound, and they're basically wanting to model the noise in the ocean. And they're taking data sets and are populating their data sets with typically academic stuff, but most of the other modeling is done through essentially looking at shipping traffic and speculating what the propagation and transmission characteristics of the ocean. So what we wanted to do is we wanted to, put sound collectors out in the ocean. We're using transoceanic sailors. And I was working with this other organization, that Hello Ocean, who works with transoceanic sailors and use that opportunity to verify the models. So they would basically be going across the ocean, take a little break, drop a hydrophone in the water, and actually do a data point and see if we could use that. It's still an important project, but to someone who's a funder, it sounds a little abstract. So I think maybe we can reinvigorate that after we, publish on this recent project we did in Alaska and also the Farallones thing. Once we get that going, I think we'll be able to restart the Citizen Science Sailors project.
When you say drop a hydrophone into the ocean, exactly what's entailed in that, and what powers these hydrophones, and enables them to communicate data with you?
Well, you can buy a hydrophone. A calibrated hydrophone costs about $1,000, but one that is reasonably calibrated, costs a couple $100. So what we were proposing doing is getting these hydrophones with preamplifiers, and they would be on anywhere from 10 to 30 meter wire. You just drop it down in the water and you record for some period of time. And because you're not highly calibrated, but reasonably calibrated, so we could get essentially an instrument set for $1,000 on a boat that was reasonably calibrated, that we could actually use as a data point to help verify what the models are.
Okay, so basically they have to be there sort of managing that aspect of the capture. It has to be done while they're there. It's not something you could leave behind and, measure a couple months later or something. They take it with them.
Yeah, transoceanic sailors, they're on these boats for long periods of time, and they, something to do. It's interesting. It's science. What may thwart this as far as the project is there are now people with NOAA launching these. They're essentially autonomous vessels that are vehicles that are going down, and they're measuring things like sound and temperature and salinity and pH and what have you. And then they're coming up to the surface and they're beaming that off to satellites. So in effect, if that program may eclipse what we're trying to do, at least from a data point, acoustic data points verification standpoint. But it's also, the side of it too, because the people from Hello Ocean were basic ocean communicators, and they wanted people to know about the ocean that they were on. So there was that public communication side of it, which is important.
I think in the context of this, I'd be curious. So the Citizen Sailors thing, I would just imagine for listeners at home that are interested, is there a call to action? Is there like a funding towards you? What can an interested citizen do to contribute to these efforts?
The Citizen Science Sailors thing was really targeted towards people who were transoceanic sailors, people who are doing that kind of work. In terms of what people can do at home, this is another challenge that we have from a funding standpoint, because what we're doing is kind of a little bit removed from the kitchen table. So, when people ask me, what can I do to improve this situation that you're highlighting here? And I say things like, don't buy stuff from China or ride your bicycle to work. It's a systematic issue that is one of the artifacts or symptoms of it is noise in the ocean. Understanding that the ocean is an acoustic environment. Yeah, it's not like, one of the things that NRDC or biological diversity can do is they can say, the wolves are being threatened up in Wyoming, and they can have a program where by investing in, $50 donations, you can actually do something to move the needle on that. When people look at the work that we're doing here, I've got this really wonderful communications person, Daniela Huson, who's, what she's doing is she's helping people fall in love with the ocean. And, when she started working with us, we had a fairly narrow visitorship on the social networking stuff because I didn't know how to do that. And the person I had doing her job before was more of a under the hood computer person. Well, this gal's got she's got it going. We, from being, having 1,000 hits a month on Facebook, we're now getting 20,000 a week.
Wow.
And she's just letting people know that the ocean is a beautiful place, and it's great. And then occasionally we slip in one of these kind of like, okay, right now it's being threatened. We would like you to, subscribe to this or endorse this or call your senators or what have you. And then, we can have more impact when people have it under their skin.
I do have one more. This is more general and contextually, I would say our initial conversation around this being a watershed moment or a chance to start things over. I'm a very big proponent of DIY methodologies and community grassroots building of things, etc. So the question I want to ask, though, is in your research and in your work about studying the ocean and the acoustics of it, if you could invent or magically create some tool to better help you do your work, what would that tool be or what would it do?
We're working on it. I wish it could come fast, but the project that we're talking about in the Farallones Sanctuary is putting a couple of hydrophone arrays that are displaced by a few kilometers from each other in the water and having that focus onto the shipping lanes. So what our objective is to look at the interactions between the ships and the boat, the whales, to try to avoid whale strike. And what we're trying to do is have those whales show up on a screen in real time. So shipping people who can see ahead of time if there's aggregations of, certain types of whales that they can avoid or slow down or what have you. But we're using a mathematical tool which called wavelet. And wavelet analysis is a lot more precise as far as giving a read. So there's a project going on down in Santa Barbara area in the Channel Islands down there that has a single hydrophone array, which is identifying when there are large aggregations of whales down there. And how they're using that is that they are basically listening to the soundscape and they have these classifying, they're looking at it and then they're doing analysis through what they call fast Fourier transform, which gives you a spectrogram. And the spectrograms that we see is basically time against frequency, and that allows us to see kind of shapes that are going on there. And that's done through, I don't want to get too technical here, but it's done through fast Fourier transform. And so you can see if they're, humpback whales or blue whales, or because they all have these classifiers that work with this visual thing that's happening. Wavelets are a little different. They essentially are able to kick a sound out, not kick a sound out, receive a sound because we're not interfering with it, and be able to determine, for example, what we do as we hear, somebody could call me on the phone I haven't heard in 30 years, and I'll say, "Hey, Bob, what's going on?" I can hear it because the characteristics of his voice, the way he pauses, whatever. Wavelets allows you to look at the characteristics of sound in a lot more finer grain detail. And so you can say, with wavelet analysis, that's not just a blue whale, but that's the blue whale named Bob, and there's Virginia and Barbara over here. It allows you to really get a fine pitch, fine grain, detailed analysis on this without interfering with the sound, which is what fast Fourier transform does, this whole filtration process. You get a lot of filter artifacts. I don't want to get too technical here, but so we're doing wavelet analysis, and we're finding that we can get a lot clearer detail on specifics about the sound as opposed to just generalities about the sound. So to answer your question, what would I want to have at my fingertips is what we're trying to get, but it's going to take a couple of years. working on it to really get it up. We have to get the hydrophones in the water. We have to get the wavelet, we have to get the mathematicians who really have that up on their screen working on it. It's a project. It's going to take a number of people, not just me.
Yeah. So I see you're going to summarize, see if I understand this correctly, you're basically going to apply wavelet analysis to this hydrophone array in order to track individuals and ideally perhaps visualize this on a map for navigators. That could be one consequence of this.
Exactly. Yeah. But what we can also do, so, the shipping lanes is important. So one of the things that Ellen Hines with Exploration Ocean Sciences, she does biological GIS stuff. So she looks at the interactions of animals in a geographical information system context. And we have a situation where we have different species of whales that are being damaged by boats in different ways. We find that the gray whales, which are predated on by orcas, will spook. They'll swim away. Humpback whales, which they're also predated on, but not to the same degree, will end up also diving when there's noise around. But when we have these large, fin whales and blue whales, these animals are not, the last 6 million years that they've been evolving, they have not had anything larger than them in the ocean moving through it. And now, it's not in their DNA to understand that there is, a 30,000 TEU Panamax, Panamax cargo ship coming at them. They don't know what to do. And it's literally at the last moment, what animals do who need to breathe, instead of diving, they surface because they need to breathe when they're freaked. So we want to unpack that those behavioral responses to the shipping noise and find out is there something we can do to help alleviate or warn these animals, to try to decrease the ship strikes that are happening, because they're happening, at a pretty high clip. I mean, over 10 whales came in on the bow bulbs of ships in 2018, in the last couple of years. Well, actually, this last year, 2019, was horrible with like 18 of them. So all these animals are getting killed. So you have two different things. One of them, they get struck in front. So you can say, okay, are these animals trying to avoid the noise and getting in front of the boats because it's quiet, because there's acoustic shadow there and getting hit? Or, what are they doing? And then there's the ones that dive, but they get stuck up in the propellers because the propellers are sucking a huge amount of water in, and they get sucked up into that. And they got these propellers that are like, 5 meters across. And so we want to look at that and see in real time what is happening with these animals and see if we can do something to try to figure out how to stop that or at least decrease it.
I have one quick question just out of curiosity. Are you familiar with the group in Santa Cruz, Conservation Metrics?
No, that sounds like an interesting idea.
There's a team, I think it's led by this PhD, Matthew McCohen, who they seem to be a bunch of academics and scientists that have now started this company where they put up microphone arrays and then do machine learning analysis of the data to track populations and individuals. I don't know much more about the specifics of it, but I do know that they are nearby and are approaching other environmental acoustic problems with similar tool sets. So it might be of interest.
Would you mind sending me a link to that?
Absolutely.
That would be great, because this is really one of the things that I've been working on for 20 years now is metrics. Because the challenge that we have in terms of regulatory guidelines, as well as just understanding what's going on, is to have a metric that explains more clearly what's happened. And so I'm on the American National Standards Institute Underwater Acoustics Committee, SC3, and also on the International Standards Organization Committee on underwater sound, because we need to have ways of expressing the sound in the ocean so that it more accurately represents what's going on. And so metrics are super important. And the metrics are getting more complicated, and the metrics we're using for regulatory guidelines are just very rudimentary, So we need to actually get into this a little bit more clearly. So I'd really, if you could send me there, context, I would really appreciate that.
Absolutely.
Well, thank you. And is there anything else you'd like to share with us?
We got a lot of work to do, but I appreciate you taking the effort here, and I really look forward to hearing more of your podcast. And Philip, I look forward to seeing what you're up to.
Thanks so much, Michael. Really great talking with you.
Yeah, likewise. Thanks.
I'd like to thank Michael Stalker and also my co-host, Phil Hermans. Phil is a musician, an educator, and a computer programmer. He's also done a lot of work in acoustic ecology. You can learn more about Michael Stalker and ocean conservation research at ocr.org. You can also make a donation there to their projects. I'll put links for everything into the Soundproofist blog post that goes with this episode. Thanks for listening.